On the 10th of April 2019, the first ever images of the black hole was released by the Event Horizon Telescope collaboration. The images showed how the plasma is orbiting around the supermassive black hole at the center of the galaxy M81. Bright region shows the region coming towards us and it's traveling at the speed of light. It appears brighter when coming towards us and dimmer when going away. This is called relativistic beaming. It is confirmed that the plasma is rotating clockwise and it takes around 2 days for the plasma to complete an orbit.
Hi guys, black holes are impenetrable. No one can go inside a black hole and come out and say what they exactly saw. The black hole is a mystery. It is quite similar to Las Vegas in the world. No one knows what exactly happens inside the black hole. The true nature of the universe may lie inside the black hole. So guys, what is a black hole? What if you fall inside a black hole? Will it be visible or would it be completely dark? Let's take a journey inside the black hole. The simple question in your mind right now is, what is a black hole? A black hole is not a celestial object, which means it's not a star or a planet. It has got no matter inside it, but it has a curved space-time.
The black hole is not just a place that wraps space. It wraps the most important factor of life, which is time. It's predicted that all the matter of a black hole is condensed at a single point at the center of the black hole. This is said to be the gravitational singularity. We still don't know how this works. To understand the singularity, we need to fuse the theory of gravity with the matter in the smallest possible scale, which is said to be the quantum mechanics scale. The theory has also given a name, quantum gravity, but how it works is still a mystery to the scientists around the globe.
How can we talk about the size of a black hole? The size of a black hole is in terms of its event horizon, which is a sphere around the singularity. It is completely dark inside. Nothing can escape from it except for Hawking radiation.
It is similar to the edge of a waterfall, beyond which the space is actually falling faster than the speed of light.
The radius of the event horizon is said to be the Schwarzschild radius. The equations were developed by the physicist Carl Schwarzschild by using the equations of Einstein. Einstein told that anything with a mass can become a black hole if they are being compressed enough. For an example, if we compress the entire mass of the Earth to a marble as small as this, which is around 1 inch, it can be turned into a black hole. If we compress the Sun to a smaller radius, we can observe a black hole there too. So guys, what lies beyond the event horizon? That is a mystery.
Let's have a journey into a black hole and observe how it is. Here we have a stimulation of a black hole. If the black hole is more massive, it would create less danger. This is because the density of the black hole would be less here. So it has less danger from ripping things apart when the mass of the black hole tends to increase, because the density would be decreased. It can be shown by the equation here.
So guys, what's the Schwarzschild radius? The Schwarzschild radius is the radius of the event horizon, and it can be given by the equation Rs is equal to 2 times gm over c squared, where g is the gravitational constant, m is the mass, and c is the velocity of light. And the volume of the sphere is given by 4/3 5 Rs cubed. So as you can see, when the mass is being doubled, we can see an increase of the radius, which is also being doubled. When the radius is doubled, we can see that the volume is multiplied by 8 times. So what happens to the density? The density is always equal to the mass over volume. So when the mass is increased, the volume is increased by a factor which is greater than the factor of mass. So what happens to density eventually is the density would decrease. This is what happens when the mass of the black hole increases.
In empty space, light will travel in straight lines. But when it reaches an object as massive as our Sun, the immense gravity will warp space, and the straight path of light curves when it passes the Sun. This is why the probe we sent has a curving path when it reaches the black hole. The black hole's gravity will warp the space. As it's a curved space, everything that enters will follow a curved path. This includes light as well. The gravity is so strong near a black hole. The space is warped and it distorts light all around it. The closer and closer you get to a black hole, you will get sucked into it by the tidal forces of gravity, which is so strong where you will end up getting spaghettified. The animation here shows the spaghettification of a star as it's been sucked by a supermassive black hole during a tidal disruption event, and also how it blasts off materials outwards from it. Sagittarius A star is a 4 million solar mass supermassive black hole at the center of our galaxy. When you approach the event horizon, at the outer event horizon, nothing would really happen, but it's a point of no return. Tidal forces are not that strong to rip you apart or spaghettify you. But when you are about to enter the event horizon, the outside of the universe appears to be more brighter and blue shifted. As you are inside the event horizon, where there is no black hole found, mass inflation stability instantaneously rips the wormhole apart. The instability is due to the energy and the apparent gravity, which is really strong, by the incoming positive energy and outgoing negative energy. This energy would vaporize you when you reach towards the inner event horizon, which would happen so quickly that you would not even at least feel what's happening. After reaching Gargantua, Cooper and crew decide to land on Miller's planet. The massive black hole's gravitational pull causes the time shifting in the Miller's planet. The space-time on Miller's planet is warped, and this is explained by the Einstein's theory of relativity.
Let's assume this to be an astronaut and the black dot here to be a black hole in outer space, and we are in a reference frame outside looking into it. His spacesuit is super strong and can withstand very high energy radiation. What happens when he gets closer and closer to the black hole? When he gets closer, we can see his speed increases as he gets closer, but he appears to be redder and fainter. When he is moving closer and closer, we can see that he is disappearing at a particular instant. So what happens here? What happens here is that the light is very much redshifted. But if we see him somehow, we can observe that he is stationary. Why does this happen? This happens at the event horizon. He comes to a complete stop here with respect to us because of the gravitational time dilation discussed by Einstein's theory of special relativity. When the gravity is so large, it appears to be stationary and it's moving at speed of light. When the observer gets closer and closer, the space-time would be having more multiple images. The black hole is completely dark inside. If he observes it from the outside, when he observes it from the inside to the outside of the universe, he can see everything being blue shifted. And also what happens to the astronaut here? We can see he will be functioning in the way he wants, but what we see is he is at rest, so the time he has is traveling very much slower than the time we have here. Let's assume that the astronaut has a time frame which is 1 hour, which is equal to 10 years in the Earth reference frame. So when the astronaut has traveled for 7 hours we can assume that a newborn baby would be age 70 when he is at Earth.
He would accelerate towards the singularity if he turns on his spacejet. Time becomes space inside a black hole. Time is moving in our universe and space is what's moving in the event horizon. The time moves to the future for us, but inside the event horizon, all move towards the singularity. And when he reaches the singularity, he would be crushed down to the fundamental particles at the end and spaghettify.
So guys, is there a chance for the astronaut to survive when he is reaching towards the singularity? There are two chances in fact. One is his suit is being strong enough. And what is the other factor?
Black holes are usually spinning and they have a tendency of forming wormholes. The scene here shows how Cooper and his crew travel through a wormhole near the planet Saturn, opening to a new galaxy. In the thriller sci-fi movie Interstellar, they reach a black hole situated 10 billion light years from Earth named Gigantua. Even at present, traveling through a wormhole or even the existence of a wormhole is an unsolved mystery. This concept emerged from the Einstein's theory of general relativity.
So guys, how was the journey inside the black hole? It was an interesting one, right? Hope you guys enjoyed the video. Have a nice day.